Hello, I'm Magnus H. Kaspersen, and today I'm excited to share insights from our paper titled From Primary Education to Premium Workforce, drawing on K-12 approaches for developing AI literacy. I co-wrote the paper with Line Have Musaeus, Karl-Emil, Kjær, Bilstrup, Marianne, Petersen, Sejer, Iversen, Christian Dindler, and Peter Dalsgaard, all from Aarhus University in Denmark. The study was funded by the Shaping Digital Citizenship project at Aarhus University and by a research grant from IT Vest. In the paper, we present a study drawing on child-computer interaction approaches to enhance AI literacy in the workplace. Our study is motivated by the urgent need to foster AI literacy among adult professionals against the backdrop of rapidly evolving AI applications across industries. In recent years, studies promoting AI literacy have been flourishing in the child-computer interaction community, aiming to prepare children for a future in which artificial intelligence plays a major role. Studies in child-computer interaction aims not only to teach children the fundamental concepts and practices behind AI and machine learning, but also focuses on computational empowerment. That is, instilling in young learners the belief they can put their computational identity into action in authentic and meaningful ways on issues that matter to them. As we see it, these competencies are equally important to people already in the workforce. However, there's a lack of empirical studies in the broader HCI community studying how to design tools and activities to teach these competencies. Thus, the central question guiding our research is: to what extent might approaches from child-computer interaction be employed to improve adult professionals' knowledge, self-efficacy, and empowerment in regards to machine learning and AI? We partnered with the Danish Trade Union for Academic Employees, DM, to design a workshop for their members. We hosted 3 workshops where we engaged a total of 53 professionals varying in age, gender, and industry sectors, from university employees to employees in the transportation and finance sectors. We collected data from questionnaires immediately before and after the workshops, and in a retention questionnaire 3 months after the first workshop. In addition, we analyzed the artifacts produced by the participants during the workshop. The workshop format draws heavily on child-computer interaction-inspired elements, including the CEML model for teaching fundamental AI concepts and practices, the DORIT model for critical analysis, and mlmachine.org to engage participants in hands-on experiences with machine learning. First, participants were given a brief introduction to AI and machine learning. Then they used mlmachine.org in conjunction with a microbit, allowing them to quickly train a simple classification model to recognize different gestures and gain familiarity with how machine learning works by collecting data, training a model on this data, and then using the output of the model to guess which gesture is being made. Moving on, participants then underwent a design process in which they first ideated and came up with an idea for how AI could be used in their work lives. Then they described this idea using a template that helps them define a pseudo-functional AI system. Finally, they used the DORIT model to further discuss and refine their ideas in a critical way. The questionnaires prompted participants about their self-reported understanding of machine learning concepts, as well as about their self-efficacy and computational empowerment, and these questionnaires are adapted from previous work. Our findings are promising. Participants demonstrated a significant increase in their self-reported knowledge of machine learning concepts and practices after the workshop. This success underlines the potential of child-computer interaction approaches in adult learning contexts. On the contrary, we didn't see a significant difference concerning self-efficacy and empowerment among the participants. The participants actually scored highly in these questions in both the pre and post questionnaires, which might indicate a ceiling effect. A similar lack of results can be seen within child-computer interaction research, suggesting a deeper exploration into these areas is needed. Drawing on the concept of participatory infrastructuring, we're motivated to go beyond traditional educational settings. Our aim is to foster a sustained, community-driven approach to AI literacy, emphasizing the role of trade unions and professional organizations in general in facilitating learning and empowerment about AI. The union, DM, has already taken steps to do so by establishing a AI special interest group with members among the participants of our workshops. We invite you to delve deeper into our paper for a comprehensive understanding of our study, its implications, and so on, and also to join us in a related presentation on the paper mlmachine.org, Infrastructuring a Research Product to Disseminate AI Literacy in Education. In that paper, we explore how we've successfully worked with participatory infrastructuring and AI literacy, but in the field of K-12 education. In conclusion, our study demonstrates the potential of child-computer interaction approaches in professional development and adult AI education, and it calls for an infrastructural approach to learning that engages a broader community in meaningful dialogue about AI literacy. Thank you for your time. We look forward to further discussions on this critical topic.